Hello, we're going to run through some derivatives, product, quotient, chain rule, trig, exponential, logarithmic, inverse functions, all that jazz. So here we go. So my first equation, or my first expression, I want to find the derivative of this quantity to the fifth, so that's going to be chain rule. So I'm going to get 5 cosecant. Inside remains the same. Drop the power down 1, so now it's to the fourth. Multiplied by the derivative of the inside. What do I mean by the inside at this point? Well, it's that cosecant. Derivative of cosecant is negative cosecant cotangent. So I've got times negative cosecant of the 3x squared minus 1 cotangent of 3x squared minus 1. And then I go further in. The derivative of the innermost part is just 6x. So as a final answer, I would probably take the 5, the negative, and the 6x and move it all to the front. So I've got negative 30x. I've got cosecant to the fourth and to the first, so I end up with cosecant to the fifth of 3x squared minus 1, and then I've got that lone cotangent. So, pretty simple chain rule, and simplified algebra, not bad. Alright, the next one. I love e's. Taking the derivative of e, copy down exactly what I see. E to the tangent. That's the easy part. Now I've got to do the derivative of the inside, which the inside is really the derivative of my exponent, but I've got chain rule there as well. Derivative of tangent is secant squared. So I've got secant squared, leave the inside exactly the same. And now I further go inside, and I compute the derivative of negative x cubed plus 2x, which is negative 3x squared plus 2. And more or less, that's my final answer. Nothing exciting to simplify. Next one, I've got a logarithmic function. It's not a natural log, so I will have an extra component to this. But the gist is that I put this inside on the bottom, so I put 1 over that, which an easier thing to do is simply flip this, write the reciprocal. So 5x squared minus 3, the square root, but I'm going to rewrite that as to the 1/2. And then I put my sine of x squared on bottom. And then the catch with anything other than natural log is I'm going to have a times the natural log of my base on bottom. So that's the easy part. 1 over my inside function with multiplying by the natural log of my base on bottom. Now I have to multiply all of this by the derivative of the inside. So I need to do quotient rule for this. So I'm going to copy low d high. So I copy the bottom down. Derivative of the top is going to be cosine of x squared times the derivative of x squared, so it's going to be times 2x cosine of x squared. Subtract high d low. I'm going to write my d low first. It's going to be 5x over 2, 5x squared minus 3 to the negative 1/2 times my sine of x squared. Where did this 5x over 2 nonsense come from? Well, I did, there it's showing up, 1/2 times my 5x squared minus 3 to the negative 1/2 times the derivative of the inside, which was 10x, so I don't know why I wrote 5x. We all make mistakes. Thank you for your patience. Because I forgot the square. That's why I didn't write the 10. Alright, so that's where that came from. Now this all goes over my bottom squared, which was that square root squared. So I've got 5x squared minus 3 on bottom. So there is my answer with calculus alone, disregarding all algebra. So if you watched my factoring video, we can clean this up a bit. So I've got this that I'm going to just copy, if I can do it nicely. There we go. And then I can factor out, so this 10x over 2 is just going to be 5x. So I can't factor out any coefficients, but I can factor out an x. And I can also factor out 5x minus 3 to the negative 1/2. And that's it. So then I've got 2 times 5x minus 3 times the cosine of x squared minus 5 sine of x squared. And this is all over 5x squared minus 3. So something you should notice is that these parts will simplify to 1, and so I just end up with x times 10x minus 3 cosine of x squared minus 5 sine of x squared all over ln of 4 times 5x squared minus 3 times sine of x squared. But really, if you can get this part right here, you're good to go. The rest is just algebra. It depends on what the context of the question is. Do you really need to simplify it? Alright, the next one, I've got something being raised to the 7th, and that something is a rational function, so I've got to do chain rule with quotient rule on the inside. So I've got 7. All of this stuff remains the same on the inside. And I drop my power down 1 times derivative of the inside. So I got low d high, which is just 3 cosine squared of x, minus high d low, which is going to end up becoming plus because my derivative of that cosine is going to be a negative sign. So I'm going to get 2 cosine of x sine of x, and that is all multiplied by the top. Parentheses, over the bottom squared, which becomes to the 4th. So now I'm ready to simplify. What can I do on top? They've each got a cosine, so I can factor out a cosine. So I've got 7. This stuff all stays the same. But I'm going to rewrite it so that we can do some more simplifying. Rewrite this as cosine 12th of x. So what am I going to do on the inside of the brackets? I am going to factor out a cosine of x, which will leave me with a cosine cubed of x on bottom instead of cosine to the 4th. So then I've got 3 cosine of x plus, I'm going to distribute that 2 in, even though it's not really necessary, 6x minus 4 times sine of x. And that is a 4 inside that parentheses. And really all I can do left is just write 7 3x minus 2 to the 6th times the cosine of x. The numerator doesn't change. And then my cosine to the 12th and cosine cubed combine to make cosine to the 5th of x. And that would be my final answer. Nothing really exciting I can do with that. So again, I did 7 times the inside left the same, dropped the power down 1, became 6, and then the derivative of the inside of all of this required that I do quotient rule. Low d high minus high d low, all over low squared. On to the next one. So this is a mess that I decided to make, apparently. Notice that I've got secant and cotangent, so I've got product rule within this problem. When it's ln, I simply put that stuff at the bottom. I will do that at the end. I'm going to put its derivative on top. So I get 3 secant squared of 5x plus 1. Derivative of secant is secant tangent, so I get secant 5x plus 1 tangent of 5x plus 1 times the derivative of the inside, which is 5. I'm going to go ahead and put that 5 at the front times the 3, which will make 15. And I copy down the other term. Not the other term, but the other function. So I've got cotangent to the 8th of 2x squared. So far so good. I took the derivative of the first. Now I'm going to add, I'm going to do the derivative of the second, but I'm just going to copy down. So I've got 8 cotangent to the 7th, 2x squared, times the derivative of the cotangent, which is negative cosecant squared. So I've got times negative cosecant squared of 2x squared, times the derivative of the inside, which is that 2x squared. So I've got times 4x, and then all of this needs to be multiplied by the secant cubed of 5x plus 1. So that is product rule. So that's my derivative of the inside of my natural log. All of this beautiful stuff goes over the original inside, which is, waiting for my s to show up, and it became a line. Secant cubed of 5x plus 1, cotangent to the 2x squared. I imagine this has a lot of simplifying I can do. What do I see? Well, I've got secant cubed in both terms. Luckily, I chose something that the coefficients have nothing in common, or unluckily. I don't know which is better. So I've got secant cubed in both terms, so I can factor out a secant cubed 5x plus 1. Because the secant squared and secant here make secant cubed. There's no other trig functions of 5x plus 1, so I've just got the cotangents that I can factor out, and I've got 7 of those. That's the smallest I can pull out. Cotangent to the 7th, 2x squared. Now the question is, what am I left with? Well, I've got a 15. I pulled out all the secants, but I still have a tangent, 5x plus 1. And I still got an extra cotangent left over on this first term. Plus, and I'm going to change that to a minus because I had that negative cosecant. I don't have any cosecants with the other guy, and I pulled out, so the 8 times the 4 gives me 32, and I've got an x as well. Pulled out all the cotangents. There were no cosecants to pull out, so I've still got my cosecant squared of 2x squared. And I took out all the secants. So that should be it. And then all of this is over the secant cubed cotangent to the 8. Now, because I had 3 of them on top and I got 3 of them on bottom, those are gone. And with cotangent to the 7th, I can just get rid of all but one of them. And there's your final answer, more or less. 15 tangent of 5x plus 1 times cotangent of 2x squared minus 32x cosecant squared of 2x squared all over cotangent of 2x squared. Now, could I technically simplify this a little bit more? Probably, because I got the cotangent and the cosecant of the 2x squared, which both have sine in the denominator. I'm not going to bother with that. There might be some simplifying you can do. So there's just some more derivative practice. Let's move on to some more exciting stuff. So now this one says find the equation of the normal line. I'm going to circle normal so I don't forget about it. When h of x is equal to 2x squared plus x, and I want to do the normal line at x equals 1. Well, the first thing I got to do is find the derivative. Well, the derivative of this, I copy it down. I multiply by the derivative of the inside, which is that exponent, so 2x plus 1. And I have to multiply by the natural log of my base. Normally you have e's, so natural log of e is simply 1, but now I've got ln of 2. So I need to find h prime of 1. H prime of 1 gives me 2 squared times 3 times the natural log of 2. So that would be my slope. And I can simplify it a bit. So I've got 2 squared is 4 times 3 is 12. So I've got 12 times the natural log of 2. Now I need to find a point, which is I get by plugging 1 into my original equation. So that'll be 2 to the 1 squared plus 1 is 2 squared is 4. So I've got a point, 1 comma 4. And I've got a slope, but this was the slope of my tangent line. So I need to actually use m, if you will, of 1 over 12 natural log of 2 negative reciprocal. So I write the equation of my line in point slope form. Y minus 4 equals negative 1 over 12 natural log of 2 times x minus 1. And life is good. If it said the tangent line, I would have just used this slope instead of the negative reciprocal. Alright, the next one is a very common one. Got to find the values of a and b such that this function is continuous and differentiable for all values of x. Well, what values of x do I really care about? And this should have said negative 1, so let's go ahead and make that a negative 1. So this should have said, let's cross that out, should have said x is greater than or equal to negative 1. Hopefully I'll fix that before I upload the document that you guys are looking at. So, to be continuous, I need the limit from the left of negative 1 as I go to x to blah blah blah. The limit as x goes to negative 1 from the left needs to be the same as the limit as x goes to negative 1 from the right. And to be differentiable, the limit as x goes to negative 1 of my derivative needs to be the same as the limit as x goes to negative 1 from the right of my derivative. So the first thing I'm going to do is limit x goes to negative 1 from the left of f of x, which means I'm just going to plug negative 1 into the top one. So I get negative 6 plus a plus 5. Then I'm going to do the limit as x goes to negative 1 from the right of f of x. And I get negative b plus 3. Set these two things equal to each other because they must be equal in order for this function to be continuous. And I should do some simple algebra before I write what I'm going to write. So I've got a minus 1 equals negative b plus 3. Now, since I don't know what this derivative is going to look like yet, I'm not going to rewrite that to potentially make it easier to work with. So I'm going to write my derivative, which is simply 18x squared plus 2ax, and then it's b. I'm not going to write the the constraints for each of those portions because you can see them to the left. So now I need to look at the limit from the left and right of this derivative. So limit as x goes to -1 from the left of f prime of x is equal to 18 minus 2a. Limit as x goes to -1 from the right of f of x is simply b. So I get, combine these two equations, set them equal to each other. Yeah, that was fun. I get b equals 18 minus 2a. So I've got two equations, two unknowns. That is a solvable system. So I'm going to work with these two. In fact, I'm probably just going to do substitution. So I've got a minus 1 equals negative b. So negative b is simply 2a minus 18. I switch the order of the subtraction. Plus 3. Subtract a from both sides. I get a on the right. Negative 18 plus 3 is negative 15. Add 15 to -1 and I get 14. So a is positive 14. Plug 14 back in and I get b equals 18 minus 2 times 14. 2 times 14 is 28. 18 minus 28 is -10. So I get a equals 14 and b equals -10. If I really wanted to check this, I would go on to Desmos and I would plot 6x cubed plus 14x squared plus 5 with restrictions x less than -1, and I would plot -10x plus 3 for restrictions x greater than or equal to -1, and they should connect, and the derivative from the left and the right, the limits should match up, so it should be a nice smooth transition. I'll let you go ahead and do that to verify. Same exact style of problem, a little bit different problem to work with though. So I'm going to go ahead and take my derivative first, so I've got everything in one spot. So f prime of x is derivative of something times, derivative of exponential function, copy it down. So I've got c e to the cosine of x times the derivative of the exponent, which is negative sine of x. Now the other one, sine of 3x over 2, my derivative is simply, well, it's not that. It's going to be 3/2 cosine of 3x over 2, and that comes from chain rule plus d. So now I'm going to be a little lazy and I'm not going to rewrite the limits because that's for you to do. I'm not taking the AP test, you are. So I'm going to do the limit as x goes to pi from the left of my f of x. So I plug in pi into the top part here. Cosine of pi is -1. E to the -1 is simply 1 over e. So I get c over e for my left limit. Now the limit as x goes to pi from the right of f of x, I'm going to plug pi in here. Sine of 3 pi over 2 is -1. So I get -1 plus pi times d. Now I go to this function here, f prime of x. Limit as I go to pi from the left. Sine of pi is 0, so the top function is simply 0. Plug pi into the bottom function, which is the limit as x goes to pi from the right of f prime of x. Cosine of 3 pi over 2 is 0, so I get 0 equals d. Now if I go back to my first set of equations, that part's gone, so I get c over e equals -1, so I end up with c equals -e. And of course I had d equals 0. And there's my answer. Again, I would plug these values in for c and d, plot it on Desmos, see that I get a continuous differentiable function, so it should be a smooth connection at x equals pi, and they should match up nicely. So, for the next problem, if f of x is this, and f of g of x equals g of f of x equals x, find g prime of 1. What does this nonsense mean? It means f and g are inverses of each other. So what I'm going to do is I'm going to write f and g, and I'm going to work with the points. So it wants me to find g prime of 1. Well, I don't know what the y value is there, but I do know that f is going to have a y value of 1 when g has an x value of 1. So I want to work with these two interchangeably, and whatever goes here is going to go here. So I need to set my original function, log base 7 of x minus 1. I have to set that equal to 1. Well, what should I do? I should add 1 to both sides, and I get log base 7 of x equals 2. If you remember your rules of logs and exponents, this is really just 7 squared equals x. So x is 49, which means this value is 49, which means my y value over here is 49. So in order to find g prime of 1, I really need to find the inverse of f prime of 49. Okay, so that will be my answer. Well, what is the derivative of f? Well, log base 7 of x minus 1. The minus 1 is just a constant, so I'm going to ignore it. My derivative of a logarithmic function is simply 1 over x, but I also have to multiply by the natural log of the base, so I get ln of 7. Natural log of 7 times x. So I'm going to plug 49 in there. So this is my f prime of x. So f prime of 49 is simply 1 over 49 times the ln of 7. So if I do 1 over that, I just end up with 49 times the natural log of 7. And that is my final answer. Now for the last question. Again, I've got given this. That just means f and g are inverses. So to find f inverse of 1, of negative 1, I want to find, and this is a typo, and the selected values of h, let's pretend this h really said g. That's what it should have said. So then this is g of x, and this is g prime of x. Please forgive my notation. So I want to find, where does g of x equal negative 1? Well, it equals it at a value of 0. So I really want to find, where am I? I want to find g prime of 0, which is 1/2. So I do 1 over 1/2, which is 2. Now for the next one, I want to find f prime of 4, so I want to find, where does g equal 4, which is at 2, and I need the derivative there, which is 1/6, and I need to flip it. So I got 1 over 1/6, which equals 6. And I am done. Thank you for watching.